We're going to now discuss special angles and coterminal angles. This will be the last video before we start to discuss trigonometry. So I call these the golden angles. That is just something I have made up. They're not officially called that, but when I discuss golden angles, it's going to be these. And I make a little note, you're going to eat, sleep, breathe these angles for this class, so you want to get comfortable with them immediately. We're going to be using them for the entire semester. Now, when we were switching in the previous videos from degrees to radians and radians to degrees, the pi's were canceling, and that doesn't always have to happen, okay? The pi doesn't always have to cancel. But the reason that was happening is because the angles that I was choosing had multiples or common factors with 360 degrees. So we want to remember the most important conversion, and the most important conversion, which is how we created our conversion, was that 360 degrees is equal to 2 pi. Okay, so the next ones are going to come directly from variations or factors of 360 degrees. So the first ones are going to be your axis angles. So that's going to be 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And I'm doing everything in positive because it's easier. But if you were to go clockwise, the radian measure will be the same, but negative. Now, of course, if you are 0 degrees, you are 0 in degrees, you are 0 in radians. So we have 0 and 360 are pretty straightforward. Now, the other 3 golden angles we're going to work with are going to be angles in quadrant 1, and those are going to be 30, 45, and 60. So the way that you easily convert these to radians is going to be to look how it compares to 360. So for example, 180 degrees is half of 360. So that means that this is going to be half of 2 pi, which will give you pi. Okay, let's look at, for example, 30 degrees. So 30 degrees is a 6 of 180. So I have a 6 of 180 degrees, but 180 degrees is pi. So this is going to give me pi over 6. I can do the same for 60 degrees. Okay, 60 degrees is a third of 180. So this will be a third times pi. So it will be pi over 3. So you just need to use the ones you know and then just divide them because they're going to be they're going to go perfectly into one of the other ones. Okay, 90 degrees. You can think of 90 degrees one of 2 ways. 90 degrees is a fourth of 360. Or it's half of 180. So let's do a fourth of 360. So 1/4 times 2 pi, which will give me pi over 2. Now, I like to think of 270, which is the way that I had told you in the first video. 270 is 3 times 90. So the best way to think about it is that it's 3 times 90 degrees, and 90 degrees is pi over 2. So this is 3 pi over 2. And then last we have 45 degrees. Okay, we can think of 45 degrees as a half of 90. So this is a half of pi over 2. So this is pi over 4. So try to use the ones that you already know, because normally people can remember 360 equals to 2 pi pretty easily. They remember 180 is equal to pi pretty easily. So use what you already know to help you with the other ones, to help you memorize them. So here are your golden angles. So we can use this trick to convert angles from degrees to radians. So for example, I'm doing 5 pi over 3. So I know that pi over 3 is 60 degrees. It's okay if you didn't remember that just yet. So let's look at the table for now. So that means that 5 pi over 3 is 5 times pi over 3. That's what it means. So this is 5 times 60 degrees, which is 300 degrees. So it's actually, I think, it's faster than using the conversion formulas. I can do it the other way, 150. So 150 degrees, I can use one of the golden angles. So which one of them goes into 150? And 30 degrees go into 150. So 150 degrees is 5 times 30 degrees. But 30 degrees is pi over 6. So this is 5 times pi over 6. So this is 5 pi over 6. Okay, one more, 11 pi over 6. This is going to be 11 times pi over 6. But pi over 6 is 30 degrees. So this is going to be 330 degrees. So it's like a little trick that if you know your golden angles, then you can convert other angles faster. You can, of course, still use the conversion formulas. It will still work, the conversion formulas, always. But this is, again, just a little trick for you to see. Okay, let's talk about the last type, little geometry review before we go to trigonometry. And the last little geometry concept we will use, again, all semester. Everything from this week is going to be used the entire semester. So we have coterminal angles. Now, coterminal angles, literally the key word is in the word in the front, which is co. So we want to draw 405 degrees. Now, 405 degrees is more than 360, which means that you have done 360 degrees. And if I take away 360 degrees from 405, that leaves me with 45. So that will put me directly into quadrant 1, right here. So this is 405 degrees. But 405 degrees lands exactly where 45 degrees is. And these are called coterminal angles. They share the same terminal ray. They are coterminal. So how do you go from coterminal angles? You can either add or subtract a full revolution in degrees, which would be 360, or you can add or subtract an angle in radians, which is 2 pi. Now, adding it will just mean that you go to the coterminal in the counterclockwise revolution. Subtracting it would just mean that you go to the coterminal angle in the clockwise revolution. And because you can go around a circle infinite amount of times, there are infinite amount of coterminal angles. So let's take a look. Now, why are we going to use coterminal angles, right? That's important. Like, why is this important for us in trigonometry? So your goal to use coterminal angles, the most important one, is going to be that we always want to work with angles between 0 to 360. Okay, so let's make a little note here. Want to work with angles from 0 to 360. Okay, and normally we include the 0 and 360 because 0 and 360 are also coterminal. Now in radians, that would be 0 and 2 pi. And if you take a look at our golden angles, all of our golden angles are from 0 to 360. So that's why, right, we're going to be working with these angles a lot. And when we have the coterminal of them, we're going to want to reduce it for us to be able to see if it's one of our golden angles. So let's take a look how we do that. So I have 4 examples, 2 in degrees, 2 in radians. So we want to find a positive angle less than 360. So that means from 0 to 360. So 560 degrees is bigger than 360. So we subtract 360 degrees. We don't want to make it bigger, we want to make it smaller. So 560 minus 360 is 200 degrees. And this is a positive angle less than 360. So here it is. So 560 and 200 are coterminal angles. They would both be in quadrant 3. Okay, the next one is going to be negative 740. So here it's negative, and we want it to be positive. So we're going to add 360 degrees because we don't want to make it smaller. We want to make it more in the positive sides. So when we do that, that's going to give us a negative 380 degrees. Right, because the way that works is you put a little 1 here, and then you take away a 6. So 14 minus 6 is 8, 6 minus 3 is 3. And then it's still negative, so we have to still add another 360 degrees. That's going to give us negative 20 degrees. But that's still negative, so we need to add another 360 degrees. And that will finally give us 340 degrees. So here is finally my angle between 0 to 360. So that means that negative 740, negative 380, negative 20, and 340 are all coterminal angles. They would all be in the same place. They would all be in quadrant 4. Okay, let's take a look in radians. So here we're going to have to add some fractions, which sometimes scares people. So the first thing you want to do when you're doing it in radians is you want to look at the denominator you're working with. So 360 degrees in radian is 2 pi. So what you do first is you change the 2 pi to be with a denominator of 6. Now, remember that to change a fraction to the denominator that you want, this currently has a denominator of 1. I want it to be a denominator of 6, but what I do to the bottom, I have to do to the top. So 6 times 2 pi is 12 pi. So you just double the 2 pi. I'm sorry, you double the 6. So 17 pi over 6 is definitely greater than 12 pi over 6. So you subtract 12 pi over 6. And this will give me 5 pi over 6. And now you can see that 5 pi over 6 is positive, and it's less than 2 pi because 2 pi is 12 pi over 6. So 17 pi over 6 and 5 pi over 6 are coterminal angle, and this would actually be in quadrant 2. And the reason I know that is because I can convert it really quickly. Pi over 6 is 30 degrees, so 5 times 30 degrees is 150. Okay, let's do the next one. So I take a look here. My denominator is 4. So I'm going to take 2 pi. I want to change it to a denominator of 4. But what I do to the bottom, I have to do to the top. So I double, it becomes 8 pi. So now I don't want to subtract. I want to add 8 pi over 4 because I don't want to make it more negative. So that's going to give me negative 21 pi over 4. That's still negative, so I have to add another 8 pi over 4. So it's going to give me negative 13 pi over 4. I got to add another 8 pi over 4 because it's still negative. That's going to give me negative 5 pi over 4. It's still negative, so I have to add another 8 pi over 4. And finally, that will put me in a positive 3 pi over 4. Now, 3 pi over 4 is also in quadrant 2. And the reason I can do this quite quickly is because pi over 4 is 45 degrees. So this is going to be 135 degrees. The question is not asking for that, but I really wanted to relate it to what we've been doing previously. So that's why I'm trying to talk about this. And again, quadrants are so important in this class. Now, there is a trick way, a faster method of doing D. And if this makes you feel uncomfortable, you can still do it one at a time. It's okay. The faster method of doing D is to look at what 2 pi is, which is 8 pi over 4, and to look at what you're trying to make positive, which is negative 29 pi over 4. So what you would do is look at, you keep adding 8s. So what you would do is look at multiples of 8. So it would be 8, 16, 24, 32. And what I would see is that I actually are going to need to add 4 revolutions to make it positive. So what you could do is add 32 pi over 4 immediately and give you 3 pi over 4. So if you know the multiples, you can add more than 1 revolution at once. Again, if that confuses you, you can just add them, right? So you can add them one at a time. So add 1, then add another one, then add another one, then add another one. This is just, if you're comfortable with it, this is just a little bit of a fast method. It would have also worked in part B, where you could have actually added 1,080. So the multiples of 360 is 360, 720, 1,080. So that would be 1 revolution, 2 revolutions, 3 revolutions. So if you are comfortable with those, you can also add more than 1 at a time or subtract more than 1 at a time.